so today's lesson, we're going to look at several different trends that we can find using the periodic table and what those trends are. All right, so periodic table trends. So the first trend that we're going to look at is going to be the trend of atomic radius. And atomic radius, that would be the size of a neutral atom. All right, so how large is the neutral atom? Now, our trend for the atomic radius, as you move down the group of a periodic table, our atomic radius increases, and as you move across the rows, then our atomic number decreases. So as you move down the columns, we increase, and across the rows, we decrease. Why is that? What is happening as I move down each time? If you think back to our Bohr model and our energy levels, hydrogen has one energy level, lithium has 1, 2 energy levels, sodium has 1, 2, 3 energy levels. So hydrogen has 1, lithium has 2, sodium has 3. So what's happening to the size is getting larger. Why? Because we are adding energy levels. As I move across, what am I adding? I go from 19 to 20, to 21 to 22 to 23, all the way over here to 31 to 32. Each one of these elements has the same number of energy levels. They are all on the 1, 2, 3, 4th row. So the energy levels is not changing. What is changing? And that is the number of protons. And what do we know about the charge of a proton? A proton is a positive charged particle. A stronger attractive force in the nucleus in terms of the protons, those positive charges, the more tightly held these electrons are to the nucleus, bringing them in closer. Think of it like a magnet. Think of it like a magnet. A magnet is going to attract something and bring it towards the magnet. All right, the next trend that we're going to look at is going to be the trend of ionization energy. What is ionization energy? Ionization energy is defined as the energy needed to remove an electron from a neutral atom. And what is our trend for ionization energy? Ionization energy is going to decrease as I go down and increase as I go across. Why? As I go down, what am I adding? Energy levels. The more energy levels, the further from the nucleus, the positively charged protons, these electrons are. So in our energy level 1, those outermost electrons are very close to the nucleus, and they are further away on energy level 3. The further away those negatively charged electrons are from the positively charged protons, the less attraction, like a magnet. If you put a magnet up on your refrigerator, if you move the magnet far enough away from the refrigerator, it will eventually no longer stick. It's not as attracted. The attraction increases the closer you get that magnet to the refrigerator. Why does my ionization energy increase as I move across? As I move across a row, my energy level stays the same. What happens? I am adding protons. More protons, and we're going to give this a name here in a few minutes when we write this down, but more protons means a higher attraction for those electrons. Therefore, if those electrons are more closely attracted to the nucleus, it's going to take more energy to remove those electrons. All right, our next one is going to be electronegativity. What is electronegativity? Electronegativity is how much an atom in a molecule attracts electrons. And this is going to be like a tug of war. Now, fluorine is our most electronegative element. All right, the most electronegative element. Now, let's talk about what this tug of war means. All right, so the way I like to think about this is if I was to take two children, and let's say they're 3 years old, and I was to put them in a room and I gave a single toy, what is going to happen with those 2 3-year-olds and only one toy? They're going to get upset with each other, right? And once one is going to grab the toy and the other's going to say, no, that's my toy, and try and grab the toy, okay? And they're going to get really upset, and there's going to become this big tug of war over the toy and who is going to get that toy. All right, so that's really what electronegativity is. All right, it's a struggle over the electron. All right, and it's the like ultimate attraction to that electron. How likely is there going to be an attraction to that electron? What happens if fluorine is the most electronegative element? Then electronegativity is going to have to increase as I move across and decrease as I move down. So I am going to increase as I move across and decrease as I move down. Why is that? Here we go. As I move across, every single one of these elements on this particular row has 2 energy levels. What is changing? What is changing is the number of protons. Fluorine has the most protons. There's only 2 energy levels. So it has a strong attractive force in the nucleus with minimal number of energy levels. As I move down the columns, what do I add? I add energy levels. More energy levels means that the electrons are further from the nucleus and there's less attraction to the nucleus. All right, what is our next one? Our next one that we're going to look at is electron affinity. Electron affinity is the change in energy that occurs when a neutral atom gains an electron. All right, so this is essentially the formation of an anion. Anions are gaining electrons. Okay, so what is going to happen here for our electron affinity? All right, so for our electron affinity, is going to decrease as I move down and increase as I move across. And ultimately, it's going to be the same reason. So essentially, each one of these trends that we've looked at has had the exact same reason why. Our final one that we're going to look at is the ionic radius. And that is simply the size of an ion. It is going to increase down and decrease across. Again, for the exact same reason. So let's get these reasons down. We've gone through them multiple times. Let's go through it one more time. And let's add in a couple of vocabulary terms. All right, so as I move down a group, so as I move down a group, what is happening? I am adding energy levels. And when I add energy levels, that brings those electrons further away from the nucleus. The more energy levels there are, the further these electrons get from the nucleus. All right, and again, a review. Energy level 1, this right here, and then energy level 3. So our electrons are coming down. This is why we look at Bohr models, because it gives us a great visual representation of where those levels are. All right, so as we add energy levels, electrons are further from the nucleus. We also have more electron shielding. What is electron shielding? That is when the core electrons shield the outermost electrons. So when we look at our picture here, my final third row here is being shielded from the second row energy level and the electrons on the first energy level. All right, so there's a less of an attractive force because these inner electrons are already more attracted to the nucleus because they are closer. So electron shielding, inner electrons shield it would help if I spelled correctly. Inner electrons shield outer electrons from the full force of the nucleus. All right, so let's talk about as we move across a period. So here's our other one. And what have we learned about as we move across a period? As you move across the period, The number of energy levels remain the same. We are simply adding protons. So as we move across a period, energy levels remain the same. We add protons. More protons in our nucleus means we have a higher effective nuclear charge. What is a higher effective nuclear charge? Nuclear, that's the nucleus. The charge of the nucleus. What is the charge of the nucleus? Positive. Why? Because of the protons, which are positively charged. The more positives, the higher the charge of the nucleus, the higher the effective nuclear charge. What is the result? The result is going to be a stronger attraction between the nucleus and electrons.